In this last example, we're just going to use the quadratic approximation now to approximate f of x equals the square root of x near x equals 1, right? We already looked at the linear approximation, so let's look at the quadratic approximation. What we need, so in this case, a is equal to 1, right? This is our a value. So we need f at a, f at 1, right? That's easy enough. We can put that in to our f of x function and get the square root of 1, right? Square root of 1 is equal to 1. Okay, so that's f of 1. And then we need f prime of a, right? So we have to take the derivative of this. So remember, we did this before, but you can either treat this f of x as x to the 1/2, or if you remember that the derivative of the square root is just going to be 1 over 2 square root of x, either way. But we put in 1 and we get 1/2, right? Just like we did before. So maybe I should write that separately though, because that doesn't, I should write that separately because that's not f of x anymore. Now it's f of 1, right? So I'm going to actually say f prime at 1 is equal to 1/2. Okay. Now we need the second derivative. Okay. Now it'll be easier if I write this as 1/2 x to the minus 1/2, right? Then I can just use the power function. And so then I'm going to bring down the minus 1/2. I get minus 1/4 x to the minus, and just subtract 1 and get 3/2. Okay. Now we just evaluate f double prime at 1. So you're going to get minus 1/4, and then 1 to any power is still 1. All right. Now, if it was something other than 1, we'd have to, like if it was 4, we'd have to recognize that this is 1, the x to the minus 3/2 is 1 over the square root cubed, right? So we could get it that way. But since it's just 1, we're just going to say, 1 to any power is 1. All right. So our second derivative at 1 is a negative 1/2. All right. So now we can write the quadratic approximation just using this formula that we have up above. So f of x is that square root function, and we're approximating it with a polynomial. And f of a is 1 plus 1/2 x minus 1, and then plus 1/2 times a negative 1/4. So how about if I just write that so I don't have to rewrite the whole thing. I'm just going to take the 1/2 times negative 1/4, and actually let's make this into a minus, right? Because it's a minus. All right. Call it. All right. So I'm taking, remember, it's plus 1/2 times the second derivative at 1. And the second derivative at 1 was a negative 1/4. So negative 1/4 times 1/2 is a negative 1/8. So I'm going to write it this way. So it's minus 1/8 times x minus 1 squared. And that's our quadratic approximation for the square root of x. All right, now you don't have to FOIL anything out. You don't have to simplify that. Just leave it that way. It's perfectly fine. It's actually easier to use this way. So here we want to approximate the square root of x, so our square root of 1.1. So square root of 1.1, that is our square root of x is f of x. So square root of 1.1 is essentially f at 1.1. Okay, and that will be approximately equal to 1 plus 1/2 times 1.1 minus 1 minus 1/8 times 1.1 minus 1 squared. All right, now it says without a calculator. Oh my God, what are we going to do? What are we going to do? All right, well, we can work with this. This is fractions. So this is 1, and this will be 1/2 times 1/10, right? Because 1.1 minus 1 is 1/10. So this is just 1/20, right? And then it's minus 1/8. Now 1/10 squared is 1/100th, and then times an eighth, we're going to get 1 over 800. Okay, get some practice with working with fractions. All right, now we need a common denominator. It's probably easiest just to make it 800, right? So 800 over 800 is 1. And if I multiply by 40, then I'll get 40 over 800. That's the same as 1/20th, and then minus 1 over 800. Okay, so we can do this. So we have 800 plus 40 minus 1. So we end up with 839 over 800. Okay, if you want to approximate it with a fraction. Now, I think it's a little, if we don't have a calculator, it's a little more than 1. If you do use a calculator, let me make this blue here. If you do use a calculator, this is approximately equal to 1.04875. Okay, that's the decimal equivalent of that fraction. And if you remember from before, we said that the square root of 1.1 using our calculator was, now I'm going to take this out to a few more decimal places since we have more decimal places here to compare to, 1.048888. Okay, so we get a little, this approximation using the quadratic approximation gives us a little bit better approximation, right? The other one was like 1.05. Now we have 1.048, so it's a little better approximation than what we had before. So, and we can actually, you'll see if you take more math, I should always take more math, right? If you take some more math, you'll learn about something called Taylor polynomials, because we can add more and more terms. We could come up, this is a quadratic approximation. We're using a second degree polynomial to approximate the function, but we could keep going, right? We could add on the third derivative, make the third derivatives match, and come up with a formula for a cubic polynomial. And we'll get an even better approximation. And we could keep going. We could create a fourth degree polynomial, fifth degree, sixth degree, seventh degree, as far as we want. And those are called Taylor polynomials. But for now, we're just going to stop here. And that's the last I have in this video. So I'll meet you in class.